Hi everyone. In the given problem of course schedule 2, there are a total number of n courses that you have to take, which are labeled from 0 to number of courses minus 1. You're given an array of prerequisite where prerequisite of I is basically AI and BI, which indicates that you must take course B before you want to take course A. So you can take this example of 0, 1, which indicates that we have to take course. In order to take course 0, we have to take the prerequisite course 1. So it is almost similar to the last course schedule problem that we have solved, but there in we have to return whether it was possible for us to take the course or not. Here we will have to basically provide the order in which we must take the course. Let us take this example. We have, let's say, a prerequisite value 5, 4, 0. So we must take course 0 before we complete course 5 or 4. Similarly, in order for us to complete course 0, we must first take course 1. In order for us to complete the course 2, course 0, we must complete course 2. And in order for us to complete course 1, we must take course 3. And in order for us to complete course 3, we must take course 2. Course 2 itself does not have any prerequisite. Okay. Now I can do one thing. I can create a prerequisite map. Where whatever I said, right, I will just write it. So for the value of 0, what are the courses that I must complete? Which are the immediate values? Which are 1 and 2? So I need to complete course 1 and course 2. Then for course 1, I must complete course 3. Then for course 2, there are no prerequisites, so we are going to give it an empty list. Then for course 3, I must complete course 2. For course 4, I must complete course 0. And for course 5, I must complete course 0. So that is the basic understanding, and let me just complete it. Then how is it going to work? We're going to start from 0th value. Okay, and let me just add the output out here. And we're going to write a DFS function. How many? There are 6 values. 3, 4, 5, and 6. So we are starting from course 0. I am going to move to it has 2 requirement, right? We have to complete course 1 and course 2. So I will just do a DFS function, and here, right? Then from course 1, right, I'm going to check, right, what are the prerequisites. Then from course 1, I'm going to call a DFS function with all the requirements. So 3 is a requirement. Then from 3, I'm going to again call a DFS function with the values. But course 2 does not have any prerequisite. So I am going to set that the first course that I must complete is 2, because I found a course which does not have any prerequisite. Then I can come to 3, because 3 is also completed now, right? So it is going to return, this is going to return true. And once it is returning true, this is also going to return true, and we can add the 3 out here. Then we can add 1, and then we can come back to 0. Once I'm at 0, right, I am going to check it's another prerequisite of 0, right? It has 2 requisite. I just checked the 1. Now I'm going to check for the other one, which is 2. 2 is already been visited, right? And it is already returned true. So nothing to do. It is going to return true out here. So I'm going to return true and the value would be 0. Now the remaining course is 5 and 4. So I can add 4 and 5 in any order in this problem statement. Okay, it does not matter. But because we are looping through in a way that I'm just going to loop through, right, from course 0 to course n minus 1. So 4 is going to get added and then 5. But in your result, right, even if 5 comes before 4, it is also a correct thing. And this type of thing, right, is called topological sort. It is a concept in graph problems, and it's a pretty easy and straightforward problem. You can go and study it up. So that is the basic idea. And now in order for us, right, to track it, we are going to use two sets, which is visited one, and in case there is a cycle, then we can check it out. So cycle would occur, right? So if I'm going to iterate, right, let's say from course 0 I gone to course 1, then course 3, and course 3 has a prerequisite of course 0. So I'm again coming to course 0 in that process, right? Then that basically means it's a cycle, and I have to return false in that case. So that is the idea. And visited is like, if I've already visited 2, right, I'm going to add that 2 to visited, then 3 to visited, 1 to visited, 0 to visited. In that way it is going to work. So now let us jump to the Python solution. And I think once the Python solution is written, the solution is going to get even more clearer. The first thing that we're going to do, we are going to create our prerequisite map. So which is going to be a dictionary of I, and the initial value would be empty list for I in range 0 to num courses. Then we are going to loop through for all the courses and its prerequisite in prerequisites. PREQUISITES. Prerequisite. So it would be PREQ map of the current course dot append its prerequisite. Once that is done, right, I am going to call all the courses. I'm going to have a value of result, which is going to store the individual which is going to come first. So here I am going to check for course in range of 0 to num courses. I'm going to call if DFS of course is returning false out there, then I am going to return an empty list. Basically, right, if we are not able to complete, in case there is a cycle or it is not possible for us to complete the prerequisite to take that course, right, we can return an empty list. So that is the idea. And else we are just return the result. Now once that is done, right, I can add two more parameters. One is the cycle and other is the visited. Both of them are going to be set value. Other is also a set, and we're using set to do it. Now I'm going to call the DFS or def DFS of the course if course in cycle, then we can easily say return false. If course in visited, we can return true. And I can now, let's say one of the course has been processed, right? I have to add that to cycle. So it would be cycle dot add the current course where we are tracking it up. And now I'm going to iterate or loop through, right? All the values or all the prerequisite that is present in our prerequisite map. So it would be preq map of the current course. And here I am going to call again the DFS function with the prereq value. Prereq. In case it is returning false, then I can basically return false from here. Else, right, I can say cycle dot remove the current course. Then I can say visited dot add the current course, and also I can say result dot append the current course, and at last I can return true out here. So that is the general idea. Let me now run the code. It should work unless there are some spelling errors. As you could see, it ran successfully. Let me do one thing just for you to see the entire code. So it's a pretty straightforward problem. Although it's not very intuitive to come up with the solution, because here we are using both cycle, because you need to also keep a track of the cycle that are present. As you could see, I submitted it and it got submitted in 4 milliseconds, which is beating 82.84%. So the time complexity would be right. Would be basically the total number of nodes or total number of courses plus the total number of edges or the prerequisite that a course needs to take. So that would be the time complexity. It would be big O of node plus edges. So that's the idea. That's all for this video. See you in the next one.